Hi guys, my name is Terry. In this video, I'm going to go through the SPM trial paper for 2024, and this is Penang paper 2. Okay guys, let's start with question number 1. This from Form 4, Chapter 3, System Equation. I think this question, if you read the English version, it may be a bit confusing or misleading. Right here we have a 100 cm long wire is cut once to produce two cuts, or should I say is cut into two pieces. Both of them are bent to form two square. Now we should how would I say cancel out this equal square. It's not equal square, it's two square, right? Let me say that the first square maybe has a length of side of x. The second square maybe is a little bit bigger with the length of side of y. Okay, just to make it clear, there are two square with different length. The sum of the square is 4 to 5. Yeah, again, the language a bit confusing. You can read the bahasa version. Jumlah luas dua segi empat sama ialah 4 to 5. So you're supposed to find the length of the wire. Yeah, the two pieces of wire. So I'm going to use x and x for the length of side of the first square and y for the second one. Now we have to form two equations. The first equation is your perimeter. So your perimeter of the square is equals to, both square is equals to the length of side, or should I say the length of the wire, which is 100. So you have 4x, yeah, because your x, you have four sides, x, and y, there are four of them. 4x plus 4y, that gives us 100. Since they're all divisible by 4, as I divide by 4, x plus y is 25, y is 25 minus x. Call this equation number 1. Okay, my second equation would be the area. Take the first area, x times x is x squared, y times y is y squared. The area is 425. Call this equation number 2. We're supposed to solve them simultaneously. So let us take equation 1, sub inside equation 2. Your y is 25 minus x, you square it, equals 4 to 5. You are going to expand the bracket. 25 squared is 625. 2 times 25 is 50. And this is x squared. The result is 4 to 5. Add them up. 2x squared, 50x. 625 minus 4 to 5, that's 200. I think we can divide everybody by 2. As I divide by 2, this will be 25x, and this should be 100. And we can factorize this. A factor of 100, you can think of combination 101, 50 and 2, 25 and 4, 20 and 5. The combination that produced 25 is 20 and 5. So let's put double bracket, x, 5 and 10, sorry, 5 and 20. That will give us negative and negative here, right? X is either 5 or 20. Okay, so once you got the x value, you find your y value, you just sub inside equation number 1. Your y is 25 minus 5, which gives us 20, or 25 minus 20, which gives us 5. So the two possible length. But you are supposed to find the length of two pieces of wire, panjang dua keratan dawai. So the length of the wire, doesn't matter whichever comes first. The first one, you need to times with 4 because there are 4x here. So it's 4 times, let's say your x is 5, so that's 20. Okay, second one is 4 times 20, that will be 80. So the length of the wire will be 20 cm and 80 cm. So when you add together, the total length is 100. Okay. Okay, question number 2. This is from the chapter Indices, Surds, and Logarithm. So we're supposed to solve these two equations. The first equation is involving logarithm. Second equation is more like indices. Okay, so for the first equation, in logarithmic equation, right, you need to have all three terms involving logarithm. The one here doesn't have logarithm, so we can introduce log 33. Why do we use log 33? Because log 33 has a value of 1. Now, why do I use base 3? Because everyone else has the same base, which is base 3. Now, we keep adding log base 3 x minus 3, followed by log base 3 x. So when you add the logarithm, we multiply the number 3 of x minus 3. The result is log base 3x. Okay, so when you compare, we compare this with this. Your 3, you can multiply inside 3x minus 9 equals to x. Bring it over, 3x minus 1x is 2x. 9 negative, bring to the right hand side is positive. Your x is now 9 over 2, right? Okay, now the second one, if you were to solve this equation, this one involving surd, so it's a little bit longer. We need to square both sides. We take square root of 2s plus 5 minus square root of s minus 1. We square our left hand side as well as our right hand side. So the moment you square this, be careful, your s, the s here looks like 5, sorry. So this is 2s square root. When we square both sides, we are using the expansion of a plus b square, or a minus b square, a square 2ab and the b square. So your a is square root 2s plus 5 square root plus 2 ab 2s plus 5 and square root s minus 1, and then minus square root s minus 5 x s minus 1 square equals 4. So let us square this, cancel out the square root. The 2 here, you can leave it outside. The square root can multiply together. This is 2s plus 5 with the s minus 1. This is positive s minus 1. When you square the square root, the negative also disappear. The negative 1 here, you square it, disappear. The result is now 4. Add all this together, add all the s outside here together, you get 3s. 5 minus 1 is 4. There's a 2. You can expand this bracket first if you want. This is 2s squared. 5 minus 2 is 3. Minus 5, the result is 4. So rearrange it. You can transfer the rest to the right hand side. 2 of 2s squared plus 3s minus 5 equals to the 4 you can cancel out, left with negative 3s. Okay. Now, from here on, we can square both sides. You can actually, let me just write like this. I square the left and I square the right. So when you square the left, the 2 square becomes 4. When you square the square root disappear. You're left with this. And 3, if I square it, negative 3 squared becomes 9, 9s squared. Let us expand the bracket. This will be 8s squared plus 12s minus 20 equals to 9s squared. Bring everything over to the right hand side. You get s squared. 12s plus 20 equals to 0. What is a factor of 20? Factor of 20, we can use 2 and 10. In order to get negative 12, both must be negative. Your s is 2 or 10. Okay, now you take these two values. By right, we should sub inside to double check, because sometimes I have to tell you this, we cannot accept all the answer, because in the process of squaring both side equation, we sometimes may create additional answers. For example, today if I say x plus 1 equals to 3, naturally we say x is 2. But when we square both sides, we are creating an additional answer. This will becomes x plus 1 squared becomes 9. And when you square root it, you will get a plus minus 3. So you get one additional answer. Your x here is now minus 4, or sorry, this is by right supposed to be 2, right? Yeah, by right x supposed to be 2. So you get additional answer negative 4. Yeah, just so you know, it's not necessary I think in SPM, they would just give you only two, both answers are acceptable, so you don't have to double check. But I'm just telling you this, that by right, we should double check, because sometimes you have answer that's not supposed to be there. Yeah, it's created by squaring both sides. So here, let's take s equals to 2 and put inside, just to double check. Yeah, your left hand side, we take square root of 2 times 2 plus 5 minus square root of 2 minus 1. So this is 9. Square root of 9 is 3, right? You can use your calculator. 3 minus 1 is 2. So yes, this is okay. So we can accept s equals to 2. The second one, the first one I sub s with 2. Second one I sub s with 10. Square root of 2 times 10, which is 20. 20 plus 5 is 25. Then 25 minus 25 square root is 5. 5 minus 3, you still get 2. This is still the same as right hand side. So we know we can accept both answers. So in this case, fine, your s is either 2 or 10. Okay, let's continue. Question number 3. This is from Form 4, Chapter 8, Vectors. So in the diagram, you're given ABCD is a quadrilateral, AEF, BFD a straight line. Is given that AB equals to 2x. I'm going to label here. This is 2x. AD is y. CD is negative 3x minus half y. So it's the whole thing. CD is the whole thing. So it's negative 3x minus half y. And 2BC equals to AE. That means BC is shorter, BC is half AE. Okay, so let's begin by finding BD. Okay, BD is quite simple. We can look at the diagram. To go from B to D, I go minus 2x plus y. Okay, minus 2x plus y. So, okay, let me just turn this off. We are going to, I'm going to write here, BD is minus 2x plus y. Now for AE, I'm going to squeeze in here, because AE, right, you can see is actually twice the length of BC. Okay, we know we can find BC. BC is one, should I say, B to A to D, D to C. Just go 3, all the way lah. Yeah, the long way. Okay, I will go B to A, which is minus x. Minus because you're going opposite direction. A to D, which is y. And D to C. D to C is negative of this, because this is, we're going from C to D, right? We're going upwards. D to C is the opposite direction. So we're going downwards. So we change the negative here to positive 3x, positive half y. Now let's simplify it further. This is 2 of x plus 3 over 2y. Multiply the 2 inside. 2x plus 3y. Yeah, you got your AE already, 2x plus 3y. Now, then by using AF equals HAE, BF equals to KBD, find the values H and K. Now, you are given AF. So in order to use this AF, right, let me just rub this off. In order to use AF, right, I can go directly here, okay? AF is a multiple of AE, right? We already know AE. So let me just work out what is AF in terms of AE. So we know your AE is 2x plus 3y, multiply inside 2hx plus 3hy. Now, then let's work out the second information here. You're given BF is KBD. So in order for us to go from B to F, you can go direct using this information, or you can go B to A to F. Now, for me, I would prefer to find two versions of AF, because we already have the first version of AF, that is in terms of H. Now we want to find the second version of AF in terms of K. So I'm going to use this information, BF equals to KBD. So my second version of AF will be A to B plus B to F. My AB is 2x. My BF is this, K times of BD. So my BD, as we know, is here, minus 2x plus y. We got it earlier, right? Minus 2x plus y. So simplify this, minus 2kf, 2kx plus ky. Put them together, 2 minus 2kx plus ky, right? So I've got two versions of AF already. Now let us just compare. The first version, okay, maybe I rewrite my first version over here, 2hx plus 3hy. Okay, let me erase this. 2hx plus 3hy. Let's start by comparing coefficient of x. The number in front of x, you can see is 2h. You compare with 2 minus 2k. 2h equals 2 minus 2k. We can divide everybody by 2. So h is 1 minus k. Call this equation number 1. Then we compare the second version, the coefficient y, the second one, which is 3h, compare with k. So we can say 3h equals to k, equation number 2. Now let's solve them simultaneously. Sub equation 2 inside equation 1. We want to get rid of k. H equals to 1 minus your k is now 3h. Bring it over. 4h is 1. H is therefore 1 over 4. Now that you know the value of h, very simple. We just have to sub inside equation number 1. Number 2 doesn't matter. Or maybe I use number 2. Number 2 looks easier because you already have k written as a subject. Your k is 3h. Since your h is 1 over 4, your k is therefore 3 over 4. Okay, question number 4. This is from Form 4, Chapter 2, Quadratic Equation, quadratic functions. Okay, but this part here, we have to use SOR POR. They gave us a quadratic equation with the roots of alpha and beta, and which follow the ratio of 4 is to 5. You're supposed to find the value of t. Okay, so number 1, before you use this SOR POR, we need to rearrange the equation in general form. General form means ax squared plus bx plus c. So I'm going to bring the x squared to the right-hand side. We have x squared minus 9tx plus 80 equals to 0. Now, they gave us the root. The roots are alpha and beta. Yeah, let me write here, alpha, beta. So we can do our sum of root, SOR. Alpha plus beta is now negative b over a. Your a is 1. Your b is negative 9t. So alpha plus beta is 90. You can call this equation number 1. Then let's work out our POR. Alpha times beta is c over a. Your c is 80. A is 1. So alpha times beta is 80, equation number 2. Now, notice we cannot solve this yet. Why? Because this equation contains, this alpha, beta contain 2 unknown each, right? And then you still have another t in your first equation, the 9t. So we need more information. So the third information is in the form of this ratio here. So if they say the roots are in the ratio of 4 is to 5, that means we know the ratio of alpha divided by beta is 4 over 5. So here we can say alpha is therefore 4 over 5 beta. And we'll call this equation number 3. Now, notice we cannot solve equation 1 yet because equation 1 has 3 unknown. We can solve equation number 3 and equation number 2. So I'm going to sub equation 3 inside equation 2. My alpha is 4 over 5 beta. I multiply with beta, I get 80. Beta times beta is going to give us beta squared. 80 divided 4 is 20. 20 times 5 is 100. So your beta is square root 100, which is plus minus 10. Now, we don't know whether the roots are positive or negative. The question didn't mention. So that's why we have to take both plus minus 10. And from here on, we can sub inside equation number 3, find your alpha. Your alpha will be 4 over 5 of plus minus 10. Your alpha is plus minus 80, yeah? Plus minus 8. Yeah, alpha is smaller, 5, you cancel with 10, left with 2, 4 times 2, you get 8. So I'm going to write in this form first, because you don't really define what is alpha, beta. What we want is the value of t. So we need to sub in the pair of alpha, beta into equation 1. So maybe I can write this, sub inside equation 1. If your alpha is negative 8, beta should be negative 10. So the first one, your SOR is negative 8 minus 10 equals to 90. This is negative 18 divided by 9, t is negative 2. If you take alpha equals to 8, beta equals to 10, then you get 8 plus 10 equals to 90. T will be 18 divided by 9, t is 2. So the possible value of t will be minus 2 or 2. All right, with that, we have to form a new quadratic equation with the roots of alpha squared, beta squared. Now, it is given that t is now more than 0. So if your t is more than 0, right? If your t is more than 0, t has to be 2. Therefore, your alpha is 8, beta is 10. But actually, in this case, it doesn't really matter, because if you take your alpha as negative, you square it, and beta you square it, it's still going to get the positive value, right? So the new roots in this case will be your alpha, I square it, your beta, I square it, which is 64 and 100. Your new SOR will be 64 and 100, add together 164. Your new POR will be 64 times 100, which will be 6400. Sorry, 6400. Hope it's, yeah. Okay, now let's form our new equation. Your new equation is therefore x squared minus new SOR 164x, new POR 6400 equals to 0. Yeah, big number. Okay. Okay, moving on to question number 5. So this is from 5, chapter 6, trigonometric function. So let's begin. We're supposed to prove this. Now, notice that there's a mistake in the question here. There's no modulus sign here. Yeah, not supposed to have modulus sign. The modulus is meant for the second part of the graph. Okay, so to prove this identity, we start from the left-hand side. Normally, we start from the side with more number of terms. It's easier to simplify a more complicated expression rather to start with a simple expression and make it complicated, right? So we start with 2 minus secant squared. Now, for me, the basic thing is if you can change everything to sine and cos, right? That's the easiest. Secant is 1 over cos. So I change this secant square to 1 over cos square. And there's a 1 minus sine square. So we're going to combine them to 2 cos square x minus 1 over cos square x, right? Then you multiply with this 1 minus sine square. Now, we know from the basic identity, maybe I just write this here, cos square plus sine square is actually 1. So if I bring my sine square over, your cos square is 1 minus sine square, right? So in that case, right, we can actually change your 1 minus sine square here to cos square. Yeah, changes to cos square. And from here on, we can cancel cos square and cos square. You're left with 2 cos square x minus 1. Now, this 2 cos square x minus 1 is one of the formula for cos 2x. Cos 2x have 3 versions: cos square, minus sine square. This is the first version. Second one is 2 cos square x minus 1. The third one is 1 minus 2 sine square. So I hope you remember the formula is given in exam anyway. So we can straight away convert this to cos 2x, and that is equals to your right hand side. All right. Okay. Part A, we are done. Now have a look at part B now. Actually, if you refer to the marking scheme solution is the graph is meant to be from minus pi to pi. So here either we change the question or you change the solution. So I think I'll just change the question here. Yeah, supposed to be negative pi to pi. So I'm going to start off with a simple graph of cos first, just to build up to this function. So the basic graph of cos, we should start from 1 down to -1 and come back up to 2 pi. So the moment you modulus it, you will have like this. Okay, maximum 1, minimum is 0, because the moment you modulus, the part that falls below here, should I go like that for you, is reflected up. So you stop at 2 pi. Now, next we have modulus of cos 2x. Modulus cos 2x means we got to double the number of cycles. So we go 1, 2, 1 cycle like this, continue, 2 cycle. But an interesting thing about this question is that we are not drawing from 0 to 2 pi. In fact, we're drawing from negative pi to pi. But let me handle this first. Let me handle, because there's more things to go. Let's handle the 2 in front. There is a 2 in front of your modulus. So the moment you add a 2 in front, your amplitude is now 2. That means, okay, and I don't want to draw the whole thing, guys. I don't draw the whole thing. I'm just going to draw, let's say, from here, 1 up to pi, right? This is 2, this is 0, and we extend to the left-hand side because we want to start from negative pi now. So we go 1, up, down, up. This will be negative pi. So we're drawing from negative pi to pi. Yeah, minimum 0, maximum is 2. So let's draw a bigger version here, and I need to shift it up, shift it down by 2. There's a -2 here, shift down by 2. So let me perhaps use a ruler here, is more accurate. Okay, but because when you shift down by 2, you're not starting from 2 anymore, you're starting from 0. So your graph here, right, you need to start from 0 and may go all the way down. How low, we don't know. Okay, so I'm just going to draw something like this, right? Okay, so let's just add in, this is your y-axis, this is your x-axis, 0 is here, 1. Remember, you're drawing 1 cycle on the right, so you're going to subdivide into 4 parts. 1 cycle on the left, subdivide into another 4 parts. Okay, maybe this one I adjust a little bit. Must look like about the same, huh? Not really nice. Doesn't matter. So, and then we need to move it down. Because we did go, if you notice that this is 2 and 0, when you shift down by 2, you have to start from 0 down to -2. Okay, but we may have to go lower than -2. Maybe I just put here. Should I just, yeah, I think we do, or lower, -2, like this. Okay, so you may want to draw this dotted line to help us to get a more balanced graph. So I'm starting from 2 here. Okay, 2 is over here, all the way down. Okay, before I draw, let's plot the point. Okay, yeah, I have to think of it because my line is too long, a bit hard to draw. So let's make it a bit shorter, not too long. Not too long. Too long, a bit hard to draw. So I'm going to draw the -2 a bit higher. Okay, we can shorten this. -2 is a bit too low. So maybe here, -2. When it's very stretched out, it's a bit hard to draw. So okay, so the graph -1 is here. We start from 0. Okay, it goes down, up, down, and up. So if you want to make your graph nicer looking, you can make it thicker. When the line is thicker, it's easier to draw. When the line is too fine, a bit hard to draw, yeah, use a 2B pencil. That will make it easier. Okay, up, touches at one point, come back down. Yeah, okay. So this one also the same thing. We start from here, up. This one, okay, have to adjust. Okay, this point, curve it up. And last point, curve it down. This is negative pi over 2. This is pi over 2, this is pi. Now you can subdivide the rest, the rest will be pi over 4 and so on. Yeah, but you don't have to label every single one, okay? All right, so my graph is complete. This is the graph of y equals to 2 modulus cos 2x minus 2, very long. So you have to do one by one the transformation. So I hope you understand my transformation over here. Now, the next thing is we need to find out the number of solution to this equation. Okay, so let's begin by rearranging this equation. You notice there's a 2 secant square 1 minus sine square, which is already the same as what we are proving in part A. So, and this entire thing is cos 2x, right? So notice there's a modulus here. So I'm going to rewrite here. This is B Roman 1, Roman 2. I'm going to change my entire expression here, this entire expression here, convert it to cos 2x, okay? And this is equals to 3x plus 2 pi. Now, next, I'm going to divide everybody by 3 pi. Reason being, I need to rearrange the equation such that one side of the equation equals to this, 2 cos 2x minus 2. So when I divide by 3, I get 2. Divide by pi, the pi cancel out, disappear. This will be 3 divided 3 is 1x over pi and 2 over 3. Now, I still need to minus 2. So let us just minus 2 on the left. And let us minus 2 on the right. 2 over 3 minus 2 is negative 4 over 3. So the straight line that you have to draw is x over pi minus 4 over 3. Okay, that's your straight line. Okay, for this straight line, right, in order for you to draw on your graph the same axis, right, it's better for us to use a table of values. Now, here I'm going to use negative pi. You can add in 0 if you want, and you add in pi. So actually 2 points is sufficient. I use one more point for backup for me to double check. Imagine putting negative pi inside here. Negative pi divided pi is negative 1. Negative 1 minus 4, 3, negative 7 over 3. If you put 0 inside, you should get negative 4 over 3. If you put pi inside, you get 1. Pi over pi is 1. 1 minus 4 over 3, negative 1 over 3. Okay, so where is negative 7 over 3? Okay, negative 7 over 3 is negative 2, 1 over 3, slightly below. Yeah, negative 7 over 3. So I need to add in a point here. Now here I'm going to use a different color pen. Now you don't have to. I just want to show you the difference. One. Second, I want to put my negative 1 over 3. Should be around here. Negative 1 over 3. Around here. Now you want to add in the third point. The third point will be 0, negative 4 over 3. Now I'm going to take my ruler, pencil, connect this. Okay, let me just adjust it to adjust a little bit lower. Okay, we can see that. Now, this is the graph of y equals to x over pi minus 4/3. Remember, the number of solution to this equation is the number of intersection between these two graphs. So you can see from the graph, they intersect 1, 2, 3, 4, 5, 6. 6 points. So if you have 6 intersection, the number of solution is 6. Oops. The number of solution is a 6. Okay. All right. Okay, I hope it's not too difficult. Yep. Okay, let's move on to question number 6. This is from 4, chapter 5, progression. So here the diagram shows example of a birthday cake that has been ordered. So the bottom layer has radius of 80 cm, right? Let me just highlight for you. Radius of each subsequent layer reduced by 4. So find number of layers that made up the cake. So picture this, the lowest one has radius of 80. So we're referring to radius, right? Let me write here the radius or radii, because plural form. The first term is 80. Then it reduces by 4 cm. So in this case, it's arithmetic. It's not geometric, because it reduces by 4. So the question is, how many layers will it be? Okay, so the idea is this. The first layer looks like this. Is bigger. Then is smaller. Then is smaller. Then is smaller, 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 smaller. At one point, what happened to your radius? The radius has to be 0. So we need to know how many layers it can go up to 0. Okay, but we don't count the layer for 0, because if your layer is 0 is what? Nothing, right? There's no layer that at that level. So we just let our Tn be 0. Remember the Tn formula? Tn is for arithmetics a plus n minus 1d. My a is 80, n minus 1, my d is negative 4. The result is 80, is 0. So let's bring the 80 over, right? This is negative 4 equals negative 80. 80 divided by negative 80 divided by negative 4 is 20, n is 21. But you cannot say your answer is 21, because you don't count the layer when the height is 0. When the height is 0, there's no layer, nothing. Yeah, so your number of layers will be what? Number of layers is not 21, it's 20. At 20, you still have, right? At 20, you still have radius. But at the 21st layer, the radius is 0. So we got nothing, right? Okay, so the number of layers is 20. Now, given also the lowest cylinder height is 30 cm, and the height of each subsequent cylinder reduces by 1. So the first part A, we're talking about the radius. Second part, we're talking about the height. Okay, so and the height at first is thicker, then thinner, 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 thinner. So you want to find the volume of the bottom cylinder. Yeah, bottom, the lowest layer, if you like. So volume is pi r square h. Your radius is 80, the lowest layer. Height is 30. Just use your calculator. 80 square times 30, that will give us 192 00 00 000 with a pi. Okay, cm cube. Now next, what is the height of the cake? Now we already know the cake has 20 layer, not 21, 20 layer. And each layer, the lowest layer has height of 30. Then it reduces by 1. So your A is 30. Your common difference is negative 1. So you find the total height. So we use S20. The formula for Sn, if you remember, is n over 2, 2a plus n minus 1 d. Okay, so your n is 20, you divide by 2, 2a, n is 20, 20 minus 1, 20 minus 1, d is -1. Just use your calculator. 20 divided by 2, I can just write 10. 2 times 30 is 60. This is 19. Answer is 410 cm. Yeah? Okay, so there you go. That's the height of the cake, 410 cm. That's quite crazy, right? 4 meter. Okay, moving on to question number 7. This is from 5, chapter 3, integration. So here you're given the shaded region is part of a curve x equals fy. So area of the shaded region is 5. Find the integration of 1 to 3 to fy dy. Now remember, when you integrate respect to y, if it lies on the right-hand side, is positive. If your right lies on the left-hand side, is negative. The result of integration is negative because your x value here, they're all less than 0. The x values are less than 0. If the x value is less than 0, when you integrate it, the result integration is also negative. So for the first part, right, when you integrate 1 to 3 to fy dy, you can take out the 2, 1 to 3. All right, this is fy dy. We know this 1 to 3 fy dy represent this part here, and the area is 5, but we cannot write 5. We have to put -5 because it's on the left-hand side of the y-axis. The result integration is negative. Answer is -10. All right, that is part E. Next, the gradient function of the curve is given as this. Gradient function is dy dx. Your dy dx is px squared minus 2x. And the curve passes through 2.16 minus 2 minus 15. So you're supposed to find equation of the curve. So to find equation of the curve, you need to find the value of p as well as your c, the arbitrary constant. When you integrate, you always have a plus c. So let's start by integrating this. Okay, but I want to say this because I've seen students substituting, they find the gradient of st and then they substitute gradient st inside dy dx. That's not true. Why? Because, for example, you may have a curve like this. At this point is, let's say, -2, -15. At this point, this is 1,6. And if you join these 2 points together, you get a straight line. That straight line doesn't represent the gradient of the curve. The gradient of curve changes throughout. At this point, the gradient is this. At this point, the gradient is something else. So the gradient of the green line obviously is not the same as the gradient of the red line. So common mistake is for student to go and find the gradient of these 2 points, right? And then they sub inside dy dx, which is not true, which is incorrect. So what you need to do instead is to integrate your dy dx, your gradient function, to find equation of the curve. This is px cubed over 3. This is 2x squared over 2. I cancel it. I write x squared. 2x squared over 2. Cancel. It's just x squared plus c. Okay, I'm going to sub inside the coordinates one by one. Let's begin with 0.16. Your y is 6. Your x is 1, right? So this is p over 3 plus 6 equals to plus c equals 6. Call this equation 1. You want to simplify further by multiplying by 3 also can, or just leave it out first. Then I sub in the second coordinate, which is -2 minus 15. My y is -15. My x is -2. There's another -2 squared plus c, right? This will be -8 over 3p minus 4 plus c. So you can bring that 4 to the right-hand side. You get -8 over 3p plus c equals -11. Equation number 2. Okay, so I'm going to take equation 1. I'm going to minus equation 2. So p over 3 minus -8 over 3, that is 9 over 3. 9 over 3 is 3. C minus c is 0. 6. Wait, I think I made a mistake here. 6 There's a 15 here. You bring it over 3. This is minus. Okay, minus, plus. Okay, sorry, I made a mistake here. 6 minus 1, this is 7. Okay, so you bring this over, your C minus C disappear. 7 minus 11, 7 plus 11 is 18. Your P is 6. As we sub inside equation 1, you find your C value. This is 6 divided by 2 is divided by 3 is 2. Bring over 7 minus 2, C is 5. So now that I know my P and C, right, I can take these two values and sub inside my Y. My Y is P is 6, 6 divided by 3, x cubed minus x squared, my C is 5. Let us rewrite here, this is 2, x cubed minus x squared. My x squared looks ugly, let me fix it. Plus 5. Okay, that's your equation of the curve. Okay, let's look at question number 8 now. So this is from the chapter Coordinate Geometry, Form 4, Chapter 7. So diagram shows a quadrilateral PQRS, point M9 H plus K lies on straight line QR. So the distance M to Q, same distance as point R. So that means M is the midpoint. M to Q equals M to R. So M is the midpoint. So I think the first part here is very simple. The ratio of QMR is M is to N. State the smallest value of M and N. So if these two are equidistant, if M is a midpoint, therefore M must be 1, N must be 1 as well. All right. Now, next, you are supposed to express H in terms of K. So let me do part B here. Your M is therefore midpoint of QR, right? M is midpoint QR. So for QR, I'm going to write 2K plus 7K divided by 2, 4K plus K divided by 2. Now, M itself is 9H plus K. So we equate this with 9K over 2 followed by this is 5K over 2. Now, actually, in this case, we can find exact value of H and K, but we don't want to find that. First, we want to find H in terms of K. So let us compare our Y coordinate. Your H plus K is now 5K over 2. If you compare X coordinate, you will be able to find the value of K. I'm not finding the value of K, I'm finding H in terms of K. So as you bring the K over, 5K over 2 minus 1K is 3 over 2K. You got your H in terms of K. All right, next, find the possible values of L when the area of quadrilateral is 105. Hence, state the coordinate of point S. Okay, now, if this asks for possible value of L, where L is the Y coordinate here, L minus 2 is the Y coordinate point S, you need to find the value K. So I'm going to compare my X coordinate of my midpoint here, right? Let's compare. We know that 9K over 2 is 9, K is 2, okay? So once you got your K, we're going to sub inside your H, 3 over 2 times 2, your H is 3. Okay, I've got all this already. Now, next, maybe it's better we sub everything inside. Your Q, right? K is 2. 2 times 2, this is 4. 4 times 2, this is 8. R here will be 7 times 2, 14. And this is 2. S will be 4 times 2 is 8. L minus 2. Okay. Now, in this case, right, actually, by right, when we are given coordinate point S, right, you can see the position point S is below here. So when you use clockwise direction, you will get a negative value. Since area cannot be negative, so normally you modulus, right? You modulus negative 105, get 105. But your calculation, you have to equate to -8, negative value, negative 8, negative value. So I would prefer to use anti-clockwise because anti-clockwise is going to be positive, and the diagram is already given. So we know L must take a specific value, right? It won't be two answers for L, it'll be only one answer. If the diagram is not given, then there are two possibilities, because you can do, for example, PQ, let's say for example, I can choose PQRS like this. Okay, this is negative. This should I do like this? 1, or it can be PQRS over here, right? The quadrilateral can look like this, right? The quadrilateral not necessarily a rectangle. It can be a shape like this, yeah, a funny looking shape. Okay, so I'm going to take my area as half x1, y1. I start with P, 0, 2, followed by S, 8, L minus 2, followed by R, 14, 2, followed by Q, 4, 8. Repeat the first point. The result is 105. Okay, so I'm going to multiply downwards first. 1, 2, 3, 4, minus multiply upwards. 1, 2, 3, 4. So this is going to give us 0 times L minus 2 plus 8 times 2. Remember, in the new SPM marking scheme, you need to show all this working. Okay, so that's the annoying part. You got to, yeah, show one by one. So I may not have enough space here. So I'm going to do the minus on the next line. Yeah, I'm going to put minus. The next line, this is 2 times 8. And this is L minus 2 times 14. There's a 14 here. And then 2 times 4. And then 8 times 0. The result is, let us take 108 times 2, 105 times 2, 210. Okay, the L times 0, L minus 2 times 0 is just 0. No need to write down. So you have 16 here. 14 times 8 is 112. 4 times 2 is 8. Minus, let me put 16 here. 14 L minus 28 plus 8. The result is 210. Okay. Sorry, very little space. Okay, now for me, I want to cancel this 2 because it's easier. 16 and 16 can cancel. I don't want to count too many. 8 and 8, you can cancel, right? The 112, you can minus 28. 112 plus 28 is 140. You minus 14L, the result is 210. So 14L is 140 minus 210, negative 70. When you divide by 14, your L is -5. Yeah. So notice I only use anti-clockwise because the diagram is given. Anti-clockwise is going to be positive. If you use clockwise, then your L value will be something else that we have to reject anyway, right? So only one answer for L. Now, also we need to find the coordinate point S. Take the L value, sub inside here. Your coordinate point S is therefore 8 and -5 minus 2, which is 8 minus 7. It makes perfect sense, right? You guys can see your L is below, is negative, right? Okay, let us move on to question number 9. This is from the chapter Linear Law, Form 4, chapter 6. So here the table shows two variables. It's supposed to be x and y. The paper here made a mistake. X and y obtained from an experiment. It's known that x and y are related by this equation. Square root y over x equals to a plus 1 over bx, where a, b are constant. So here we're supposed to construct a table of values for square root y. Now, based on this y value here, I'm going to rewrite my square root y over here. Use your calculator. Okay, let us square root 0.15. First, the first one, you should get 0.39. Yeah, 0.39. Okay, then we move on to 0.5. Square root 0.5, you should get 0.71. Okay, next one, square root 1 is just 1. I'm going to write 1.00. followed by square root of 1.7. That gives us 1.31. Okay, next square root 2.5, square root 2.5, that gives us 1.58. And lastly, square root 3.6, square root 3.6. Answer is 1.90. Okay, so I've got my table of values. Now, the next thing is I want to show you how to use your calculator to predict your answer. You want to find gradient y-intercept from this straight line graph, okay? So we can do so by using calculator. First, we go to mode, go to number 6 for statistic, go to number 2, y equals a plus bx, right? We're going to key in the x and y value. Notice your x value starts from 1, go on to 2, 3, 4, 5, and 6. Okay, then you move on to your y value. My first y value is 0.39, second y value is 0.71, next is 1, okay, followed by 1.31 and 1.58, and lastly 1.90. Okay, so yep, I've got all this value key in. Go to AC, go to OPTN for option, go to number 3 for regression calculator, and then you can see that your A here is your y-intercept. Your y-intercept is 0.10. Let me write it down. Y-intercept 0.10 or 0.1 will do. B is your gradient. Your gradient is 0.299. We can just take 0.3. Okay, right. R here is coefficient regression, is not important, but normally your R value is close to 1 or close to -1. -1 when the gradient is negative, +1 when the gradient is positive. So 0.99 means all the points are very close, or most of the points, if not all the points, are on the line of best fit. Okay, all right. So using the scale of 2 cm to 1 unit on the x-axis, so I'm going to start plotting 2 cm to 1 unit. So this is 0, 1, 2. Maybe I zoom in a bit hard to see. 1, 2, a bit more. 3, 4. Oh, this is hard to see. Okay. 5, 6. Largest is 6. This is your x. For your y-axis is 0.2. So we start with 0.2, 0.4, 0.6, and so on. 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. My largest is 1.9. So 2.0 is more than enough. So your y value is square y. Okay, so now next maybe I draw the line here, add in the line so it looks clearer. This is your horizontal axis over here. Okay, then we draw a vertical axis. Okay, over here. Okay, my graph is done. Okay, my axis is done. Okay, so let's plot the point one by one. Now let's begin with the first point is 1 and 0.39. 1, 0.39. 0.39 is close to 0.4. Remember, this one big box is 2, one small box is 0. One big box is 0.2, one small is 0.02. So 0.39 should be around here, 0.39. Okay, now next you have 2 and 0.71, 0.71. Okay, is here. Next, we have 1 and 1. Sorry, 3 and 1. 3 and 1. Next, you have 4 and 1.31. 1.31. This is 1.32. 1.31 is over here. Next, 5 and 1.58. 1.58. Let me zoom in a bit more. Okay, 1.58. 6 and 1.9. 6 and 1.9. Okay, so I think all the points are done. And we know the y-intercept is supposed to be 0.1, so I'm going to label 0.1 here. So this is the correct y-intercept. So just draw the line, make sure it passes through as many points as possible. Yep, it looks something like this. Maybe I need to drag this down a little bit. Yeah. Okay, it's not good enough. Think perhaps you can adjust one more time. So it's a bit difficult sometimes to draw the line of best fit. I got to be patient, go through every single point if possible. So it looks like that. Okay, notice that the first, should I say, the first point is slightly below, second and third point is slightly, second and fourth point is slightly above, right? And okay, I think I haven't connect the last one yet. So I need another, extend a little bit. Okay, wait, let's start from 0.1. Once again, extend all the way up. Make sure it go through the last one. Okay, yep, this is a bit better. First point a bit, second point a bit lower here. Okay, you can see that the first point and the fifth point is a bit below the x-axis, right? Below the line of best fit, sorry. Could it be better? I think it could be better. Yeah. It looks like this is a bit. Okay. Check again. Is my y-intercept correct? Zoom in a bit. Okay, I think I need to move my point a bit lower. My 0.1 is not it's not really good. Move this a bit lower. Yeah, this is better. Second point you can see is above. Okay. And the fourth point is above, fifth point below. Yeah, first point below. So it's okay. I think it's quite balanced. Yeah. The line of best fit is okay. Quite balanced. Could be better, but I think it's okay. All right. Now, after getting this graph done, we need to calculate two things, gradient and y-intercept. So for gradient, right, I will take 2 points. The first point I will take 0 and 0.1, which is your y-intercept. Second point, I'll move 5 unit across and read from here. Now, why do I use 5 unit across? Because 5 boxes across, because any number divided by 5 is always a nice number. So this is 5 and 1.6. Remember to take the point on the line of best fit, not the point from the table, because sometimes the point doesn't lie on line of best fit. As you can see, at this point here, does not lie on the line of best fit. So my gradient will be 1.6 minus 0.1 divided by 5 minus 0. Okay, now use a calculator and let's count. Okay, go back to menu. Okay, 1.6 minus 1 is 1.5. If you divide by, okay, 1.5, you can write minus 0.1. Divide by 5, you should get 0.3. Okay, 0.3, which is exactly the same as what we have gotten from the calculator in the first place. Yeah, 0.3. So my y-intercept is 0.1, my gradient is 0.3. Now then use the graph to find the value of x when y is 0.67. Yeah, my graph is done. I want to find first the value of x when y is 0.67. Okay, when your y is 0.67, what is the square root of y? Square root of 0.67, we have to find 0.67. You should get 0.82. Yeah, 0.82. So 0.82 is around here, 0.82. I just have to move across and move it down. Okay, it looks like it is 2.4. Yeah, 2.4. All right, so from the graph, your x is 2.4. Okay, no problem. This is Roman 1. Okay, Roman 2, I need to find the value of a and b. Now, a and b are the variable in your equation here. So we need to convert this to linear form. So let me just rewrite now here. So first of all, I'm going to multiply the x over. So you are going to get square root y equals to ax plus, when it times the x over, you cancel the second x here, 1 over b. So this is your big Y, this is your gradient, this is your big X, and this is your C. right? Your y-intercept is 1 over b, your gradient is a. Now, I've already gotten my gradient. My gradient from the graph is 0.3, from the equation is a, therefore a is 0.3. My y-intercept from the equation is 1 over b. My y-intercept from the graph is 0.1. I'm just going to invert both sides. Invert the left, invert the right. 1 divided by 0.1 b is just that. Okay? Okay, moving on to question number 2. This is from Form 5, Chapter 2, Differentiation. So you're given the equation of a curve. Yep. So I think it's best we expand the bracket. Y equals to 3, x squared minus 2 over 3, x cubed plus half. So we're supposed to find coordinate of the stationary point. Now remember, stationary point happens when the gradient dy dx is 0. So let's differentiate this. You get 6x. Bring the 3 down. 3 and 2 3 and 3 cancel, left with minus 2x squared. Differentiate half, you get 0. Now, at the stationary point, doesn't matter whether it's minimum, maximum, or inflection, all the gradient must be 0. So we let dy dx be 0 and solve for x. Here we can take out your x, right? Take out 2, left with 3 minus x equals to 0. The roots are 0 and 3. So once you got the x value, you need to find your y value. Yeah, stationary point coordinates means x and y. So when your x is 0, sub inside your y is 3 times 0, 2 over 3 times 0 plus half. This will be half. And when x is 3, your y is 3. 3 squared minus 2 over 3 times 3 cubed plus half. Okay, so use a calculator. Okay, we're gonna count 3 times 3 squared is 9, 3 times 9, minus 2 over 3 times 3 cubed is 27, then you plus half. So this is not a nice answer. It has fraction, 19 over 2. So the coordinates would be 0, half, and 3, 19 over 2. Okay, that is part A. Part B, hence, determine whether the stationary point is a maximum or minimum. Now, remember, we can compare the tangent or we can use second order differentiation. Yeah, for me, second order differentiation is easier, right? So I'm going to differentiate one more time. Take your dy dx here, differentiate for the second time. Differentiate 6x, you get 6. Differentiate minus 2x squared is negative 4x. Now let us sub in two values. With first one, x is 0. Your d2y dx squared will be 6 minus 4 times 0, which is 6. Now notice this is more than 0. If it's more than 0, we say that this coordinate is a minimum point. Okay, so it's minimum, first part, no problem. Then we go and sub x with 3. Your d2y dx squared will be 6 minus 4 times 3, 6 minus 12, negative 6, less than 0. So this second coordinate will be a maximum point. Okay, so that's it. We are done with part B. So we know one is minimum, another is maximum. Now next, they say is if x increase from 2 to 2.01, find the approximate value in y. Approximate value is simply your final value of y. Okay, now let me illustrate by using a diagram like this. So this is a curve. Now let's say you have a line that touches the curve at one point. This point here is 2. We are taking a point that's very close to 2, 2.01. So this difference is your delta x, and this difference is your delta y. So first of all, we are making an assumption that when you have a small change, right, the ratio delta y over delta x is almost equals, or we can just say is equals to the gradient dy dx at the point x equals to 2. So what we need to do is to find the gradient first. We sub x equals to 2 inside your dy dx. So your gradient dy dx is 6 times 2 minus 2 times 2 squared, which is 12 minus 8 equals 4, meaning the gradient of this line is 4. Now, next, let's find out our delta x. When you increase from 2 to 2.01, we take 2.01 minus 2, the difference is 0.01. So this is 0.01, okay? So when you get dy dx equals 4, it simply means when your x increased by 1 unit, okay, your y will increase by 4 unit. Yeah, so that's the meaning. So now if my delta x is 0.01, my delta y divide my delta x must be 4 multiplied over delta y is 0.04. Okay, now I also need to find, this is your, we call it small change in y, but we're not finding small change in y, we're finding approximate change in y. Approximate change, like I said, is the final value y. So this is your initial value y, y1. This is your y2. Y1 happens when x is 2. Take x equals 2, put inside your y. Okay, so when x equals to 2, your y is 3 times 2 square minus 2 over 3, 2 cube plus half. Now use your calculator. 3 times 3 times 2 square minus 2 over 3 times 2 cube, I could put 8 plus 1 over 2. So this is 43 over 6. Not a nice number, but yeah, this is your y1, the initial value y. So when you increase your y1 by delta y, which is 0.04, you will get your y2 or your approximate value. Yeah, your y2 is y1 plus delta y. Your y1 is 43 over 6. Your delta y is 0.04. Take this plus 0.04. The difference is 1, the value is 1051, 1081 over 150. It's not a nice number, right? Because it involves fraction. Yeah, very ugly fraction, but it's okay. Yeah, so I think we can just leave it like this as fraction. Okay. Okay, let's move on to question number 11. This is from Form 5, Chapter 5, Probability Distribution. So the first part is a normal distribution. You can see the question mentioned the masses of mangoes from an orchard, they are normally distributed with mean of 420, standard deviation of 50. So you're supposed to find the probability that a mango chosen randomly has mass not more than 400. Now, when we say not more than 400, right, means x can be less equals to 400. But in normal distribution, it doesn't matter whether it's less than or less equals, the values are the same, yeah, because the probability is measured by calculating the area under the graph. So if let's say, for example, 400 is here, area under the graph for one thin line for exactly 400 is just 0, okay? So you don't bother about less equals or less than, they're all the same. So here, number one, you're going to standardize, change from x to z. Remember, you cannot calculate the probability directly, you have to convert it to a standard normal distribution by taking your x value minus your mean, 420, divide standard deviation 50. So this is 420 over 50, or negative 0.4 is negative. Okay, now to calculate the z value, right? To calculate the probability from the z value, we use what we call the upper tail probability. All right, so for 0.4, you can see it's over here. It's just 0.3446. Okay, let's go back to this. But this is negative. Yeah. We should just flip it over to the right hand side, because your table cannot read negative, can only read positive, right? So I flip over to the right hand side. So it's equals to this. And from our table, we got 3446. Now, you can also use your calculator, because this calculator can actually calculate directly here without using table. We press menu, go to number 7. You can see 7 here is for distribution. Go to number 2 for normal distribution. Remember, a normal distribution here, we're using upper tail. Upper tail starts from your z value, 0.4. We go all the way up to infinity. Infinity, in this case, we write 999. You can put more 9, doesn't matter. And standard deviation is 1, and so on. You see, you will get the same answer, 0.3446. All right, that is Roman 1. Okay, Roman 2, you want to find the value of m if 70% of the mango have mass of more than m. So 70% more than m. So x more than m equals 0.7. Okay. Now, we need to standardize this. Change from x to z, m minus 420 divide by 50. This is 0.7. Now, to understand where is the position of this, I would recommend that you use this three-step method. Number one, we fix the position. Now, when I say fix the position, right, we are fixing the location of this m minus 420 over 550. It has two possibilities, either left or right. Remember, the middle line for standard normal distribution is 0. So let's say, assuming I'm not sure, I just put right hand side. Okay, this is m minus 420 over 50. Number two, I need to shade the region. Shading the region depends on the symbol here. Look at this. This is more than. More than means I shade on the right hand side. And number three, you got to check whether the probability matches the area here. Now notice the probability is 0.7, which is more than half. If your area is more than half, yeah, it cannot be this, right? So we know this is wrong. Your diagram doesn't match the probability, so it cannot be, on the right hand side. So what do? You repeat step one. You draw this again, but this time I fix it on the left hand side. This is my m minus 420 over 50. Greater than is to the right hand side. So ask yourself, can this be 0.7? Answer is yes. So this is correct. Now you can do 1 minus now. 1 minus, because remember, you cannot read the bigger side. You got to read the smaller side, and you got to read the upper tail. That's the problem. So we're going to write px less than m minus 420 over 50 here, and this is 0.7. Switch this over, m minus 420 over 50. 1 minus 0.7 is 0.3. So you got to read 0.3 and work backwards to find the z value. Okay, so what I'll do is I'm going to flip this to the right, because I know this is 0.3, but I cannot read 0.3 from the left. I'm going to read from the right. Yeah, so let's go back to your mathematical table. All right, where's 0.3? So let's find. Read inside the region here, because your given area or probability, you're finding the z value. So the closest I can see is 0.3, right? I need to go slightly more than 0.3. Remember, I'm finding 0.3. I have 0.3015. So I need to subtract the last two digits here, 15. As we move across, we don't have 15, we have 14, the closest. So I need to subtract 14 so that I get 3001, which is close enough. Now, how do you read the z value? We read 0.5 to 4. Yeah, 0.5 to 4. Okay, let me clear this. All right, let's go back to your question here. I know this will be 0.524. But notice that this is what I got from the table. It's on the right. But this graph that I've shaded, that I've sketched, is on the left-hand side. So remember, you got to flip it over because they're symmetrical, so that your m minus 420 over 50 is now negative 0.524. It's not positive, it's negative because it's on the left-hand side. That's why it's very important that you sketch, you draw it out. Yeah, a lot of people tend to miss out the negative. They just write m minus 420 over 50 equals 0.3, yeah, equals to 0.524. Eventually got the wrong answer. Now, on the other hand, you can also use your calculator. Your calculator has this function, number 7, distribution. Go to number 3, inverse normal. Your area is still 0.3, but notice that your calculator read this from the left-hand side. The calculator will give us negative value, which is okay. Yeah? So even if your graph is on the right-hand side, you see a negative, right? Just drop the negative. So notice 0.524 is the same, just drop the negative. But since this is on the left, so I add a negative here. Just one more step, use your calculator, right? We're going to take negative 0.524 multiplied by 50 plus 420. My m value is 393.8 gram. Yeah, for significant figure. All right, that's the first part, normal distribution. Okay, second part, we're going to use binomial. Yeah, it is a binomial here. Read the question. In a quiz, in the mathematics quiz, students are required to answer 40 multiple choice questions. Each question is provided with 4 possible choices where only one choice is the correct answer. Student must obtain at least 15 correct answer to pass the exam. All right. So what is your N for the objective question? What's the probability of getting a correct answer? 1/4 or 0.25. Okay. Now, then they say student A gets the answer correctly. Yeah. So now also important that they say that the student gets, because if a student have knowledge about the certain subject like mathematics, the chances of them getting the correct answer would be higher, right? So in this case, you're guessing, so the chances is always 1/4 or 0.25. Now, find the probability he will get the minimum mark to pass. So you need at least 15 to pass. So minimum mark to pass is 15. That means if you get exactly 15 correct answer, you will pass. Yeah, just pass. So it's 40 C 15 B 0.25. Oh, you remember the formula? Formula for this is x equals r, n c r, b power r, q power n minus r. This formula is given in the formula list. So this is power 15, 0.75. Your q and p, remember, plus together is always 1. Q is 1 minus p, 1 minus 0.25 is 0.75, and this is 40 minus 15. Okay, there are two ways to calculate. One is to use the manual way, type in 1 by 1, 40C 15 times 0.25 power 15, multiply 0.75 power 40 minus 15 is 25. I got 0.02819. 0.02819. This is one way. Another way is to use the function in your calculator. So this calculator can do this directly, menu, go to 7, right, for distribution. Go to number 4 for binomial PD. Go to number 2 for variable. Key in your x value. X is 15. Your n is 40. And your probability is 0.25. You should get same answer, 0.02819. All right, that is B Roman 1. Okay, let's talk about B Roman 2. If student B answer 15 question correctly and guess the answers for the rest of the question, find the probability he will get 60% marks. Okay. Now, first of all, what is 60% out of 40 question? That will be 24, right? Yeah, 60 divided by 100 times 40 is 24. Now, we also need to know how many questions he guessed. He already gotten, you can take small x or r if you like. Yeah, you can use r, maybe I use r, the formula NCR. R will be 24 minus 15 because he already answered 15 questions correctly. So he need to answer 9 questions correctly from the remaining question. So if you take 40, you minus 15, you're left with 25. So the remaining 25 questions, he need to get 9 correct. So what is the probability that he got 9 correct from the remaining 25? So it's 25 C9. Your P is still the same, 0.25 power 9. Your Q 0.75, 25 minus 9. Okay, yep. Now, again, you can use this function. You can type manually. So this time I'm going to use this function directly. Your x is 9. Your n is now 25. P is still the same, 0.25. I got 0.07811. 0.07811. Okay. Okay, moving on to question number 12. This is from Form 4, chapter 10, index number. So table 12 shows information for ingredient used in production type of food. So this is the ingredient, the price given. Okay, actually this is not written properly. This is 2022. Should I say 2024? Yeah, and using 2022 as the base here. I can see here this is 22, 24. Okay, you're supposed to first find the value of P and Q. So P is the price index for item Q. You can see item Q here, right? So your P will be 16 ringgit 20 cent divide 15 times 100. Use your calculator, all right? 1620 divide 15 times 100. I got 108. Yeah, P value is 108. Okay, how about Q? Q is the price in the base year. You can see here, price in the base year for item R. Price in the current year is 34 ringgit. The price index is 136. So we take 34 divide by Q times 100. I got 136. To find Q, we take 34. 34 at 2 more 0 times 100 at 2 more 0. Divide 136. My answer Q is 25. All right, that is part A. So part B, given that the cost of producing a box of food increases by 17% from 2022 to 2024 and 40% from 24 to 26, and the ratios are given as 6, 4, 3, R. Find the value of R. Okay, we know the value of P. My P is 108. And we know the weightage. The weightage are given in the form of ratio 6, 4, 3, 2. So when you multiply them together, divide by total weightage, you get the composite index, which is now 117. Now, when they say total cost increased by 7%, that means your composite index is 117. Okay, there is a way to write this, but again, up to you. Some teachers may that or student may write a bit differently. So normally what I write is I write 22, 24. 22 base year, 24 current year, but you can write 24/22. So same thing. Okay, yeah, it's up to you. But this is just a notation. You don't write is fine. Okay. Now take the individual price indices for each item. P is 110 multiplied by 6. Q is 108 multiplied by 4. R is 136 multiplied by 3. Wait. Then the last one, 643. Okay, last one is R. This is not 2, sorry. This is R. Last one is 120 multiplied by R. Total weightage is 643R. 643R. That will give us 117. Okay, so let's count this. 110 times 6 is 660. 108 you times with 4. Okay, then 136 you multiply by 3. This will give us 1,500 plus 120R. 6 plus 4 plus 3 is 13. So I'm going to cut short my working a little bit. 13, 117 times 13 is going to give us 1521. R times 117 is 117R. Bring it to the left. 120 minus 117 is 3R. 1521 minus 1500 is 21. 21 divided by 3. R is just 7. Okay, now next they say calculate the composite index for the cost of producing the food in the year 2026 based on the year 2022. Okay, so this is where we can use what we call the chain rule. So we use I like to use a simplified chain rule. That is, I use 3 year here, 2022, 2024, and 2026. 2022 to 24, the index is 117, composite index 117. 24 to 26, this stated earlier, increased by 40%. Yeah, 40% means 140. So we write here 140. Okay, now to find the overall increment, which is the index from 22 to 26, or we say 26 based on 22, we take 2 consecutive indices, multiply together, divide by 100. That is 117. You multiply 140, divide 100. I got 163.8. Yeah, 163.8. Okay. All right. Now, let's move on. Now, the price of a box of a food in 2022, it was 35 ringgit. Still the corresponding price in 2026. So we can use this result from Roman 2, yeah, because this is your overall increment. We know the price in 2022, which is 35 ringgit. I put the RM here, 35 ringgit. The price in 2026, I don't know. But the overall increment must be 163.8. That means it has increased by 63.4%, 0.8%. So let's take 163.8 divide 100, multiply 35 ringgit. My answer is 57 ringgit. 57 ringgit 33 cents. Okay. All right. Lastly, Find the percentage increase of ingredient P from the year 2022 to 26 if the price of all ingredient remains unchanged from 24 to 26. This is 26. Okay, so let's go back to the table just now, this one. So these are all from 2022 to 24. So just to help you to understand better, right? 22, 24, 26. So let's look at item Q. Q increased by 108. Then it remains unchanged. When it remains unchanged, the index from 24 to 26 is going to be 100. So find the overall increment, right? Normally we just take 108 times 100 divided by 100. But in this case, there is actually no point multiply 100 divided by 100 because it's going to give us 108. That means this thing doesn't change, right? From 22 to 24 is 108. 22 to 26, also 108. So your R also the same 136, S also the same 120. It's just that the P has changed. So you need to find what is the value of P, what is the index of P, right? Okay, so we're going to take the composite index. Okay, we know the composite index is, okay, actually no need to write this. This is 163.8. For P, I'm going to call it I, multiply with the weightage is 6. Remember, it's 6432. 6437, your R is 7. Second one is 1084. Next one is 1362. Last one, 120 R is 7. Divide 642. Is it 643, not 2? 6437. Okay, 6437. Okay, counter check. This is 163.8. Our job is to find I now. Okay, let's go back and see this. It is the same. Yeah, 136 and 120. P is 108. Yep, it's correct. Now let's count. Use your calculator. 108 times 4 plus 136 times 3 and 120 times 7. This will give us 1680. 6I plus 1680. This is 20. So I don't write so many steps. So I will take 20, 163.8 immediately times 20. I'll get 3276. Take this 3276 minus 1680, right? 1596. 1596. Okay. Divide by 6. Yeah, as I divide by 6, I got 266. Okay, 266 is the index. We are not finding the index. We're finding what? We're finding the percentage increase. Remember, your index is always based on 100. Anything above 100 is the difference. Like for example, when I say unchanged is 100, right? We go to 266. The difference, right, is the percentage increase. So the percentage increase or percentage is 266 minus 100. Answer 166%. Okay. Okay, moving on to question number 13. Now, this is from the chapter Solution Triangle, Form 4, chapter 9. So, diagram shows a transparent prism with rectangular base ABCD. The inclined surface ABFE is a square with length of side of 12. So, let me label 12, 12, 12, 12. And inclined surface DE is a rectangle. AED is a uniform cross-section of prism. BDE is a shaded plane in the prism. So given that ADE is 37, EAD is 45, find the length of DE. So I think we can start by redrawing this. A bit hard to see in 3D, right? So I'm going to redraw this AED. Okay, AED looks like this. This is your E. This is A. This is D. ADE is 37 degrees. This EAD is 45 degrees. Do you know this length of AE is 12? You're supposed to find length of DE. So here we can use sine ruler. Remember, sine rule comes in pair. We can write your ED first, whatever I'm finding right on top, divide by sine of the opposite side, which is 45, 12, divided by sine of the opposite side, 37, find ED. Okay, use your calculator, 12, divide sine 37, multiply with sine 45. Okay, be careful. Please use your calculator in degree mode, angle unit in degree. So that will give us 14.10. I'm using 4 significant figure, right? Okay, that is the length of ED. Now, next, area of the shaded plane. Okay, to find the area of shaded plane, we need to find more information. We need to find the length of all three sides of the shaded plane, right? So let's begin by finding, we know ED already, right? This is 14.10. We need to find BD. Before we find BD and we find AD. Now AD we can find from the same triangle here. We can use sine rule again. But I need to find the length of, should I say, the angle AED. You can also use cosine ruler. I think I will just use sine rule. AED will be 180 minus 45 minus 37. 45 plus 37 is 82. 180 minus 82 is 98. Okay, so I'm going to use sine rule once again. I write AD divide sine equals 12 divide by sine 37. Okay, now use your calculator. 12. Okay, I think I just use back this one, right? I just change this to sine 98. You can see everything else being the same. Huh? See the front one, 12 divided sine 37 times sine 98, 19.75. Yeah, AD is 19.75. Okay, it's important that you find AD first, because if I know this 19.75, it has a rectangular base, ABCD, this is 90 degree. I can find BD by using Pythagoras theorem. 12 square plus 19.75 square, put the square root over. Okay, take this one. Maybe I just type the whole thing at 19.75 again. Square plus 12 square, put the square root over. I got 23.11. Yeah, BD is 23.11. Okay, 23.11. So now I still need to find the length of BE. And B is not difficult to find because this is a square, right? This is 12, this is 12, this is 90 degree. I can calculate this by using 12 square, 12 square, square root. 12 square is 144, 144 times 2, 288. You can change to decimal, but I think it's better to leave it in surd form. Square root form is easier. Yeah, it's more accurate also. Now, once you know the length of all three sides, we can use Heron's law, yeah, to find the area. Okay, Heron's law, we got to start by finding what we call, okay, actually I labeled this wrongly. This is A, this is B, not Roman 1, Roman 2. Okay, so this is B. We use what we call semi-perimeter. So let's start with 14.10 at 19.75. Then you add, oops, I need more space here. Add square root 288, divide by 2. Okay, semi-perimeter is the perimeter, divide by 2. So let's start. 14.1 plus 19.75 plus square root 288, divide by 2. You get 25. Okay, I think I wrote this wrong. Not 19.75, is 23.11. Sorry, it's 23.11. Let me just adjust this. 19.75 is not the total, not the length. 23.11. Okay, let me do again. This is, where were we? Here, change this to 23.11. Okay. Okay, I've got 27.09. By right, we should use one more decimal point to be more accurate, because up to 5 significant figure. But since after the 9 is still 0, so it doesn't matter. We take 27.09, we'll do a 27.09. Then your formula for Heron's law, remember, is we start with S, 27.09. Then we take the difference, 27.09 minus the first 14.1, or you can write 10, 27.09 minus 23.11. Okay, let me move this a bit to the right. I need the longest. I think I need more space. This one draw a bit longer. 27.09 minus square root 288. Okay. All right. So use your calculator. Count one shot. But when you use your calculator, right, learn how to use the answer button, right? 27.09. When I press equals, it is saved as an answer. So you take a square root, answer, open bracket, answer, minus 14.1, close bracket, answer minus 23.11, followed by answer minus square root 288, okay? And you will get 119.05, yeah? 119.05. I'll take one more significant figure because I will need this answer to solve for part C. Okay, part C, you're finding the shortest length from point E to line BED. So if you look at the diagram again, maybe I redraw for you. This is E, this is B, this is D. Maybe mine is not too, maybe I should draw a bit sharper, right? It looks something like this. This is E. I'm finding the shortest distance here. So we already know the length of the base BD, 23.11, and we know the area of triangle, 119.05. I'm finding the shortest distance, which is the perpendicular distance, which is the height of the triangle. We can just use half times base times height and let it be 119.05. To find the value of h, just take this answer, 119.05, multiply by 2, divide 23.11. Okay, you will get 10.30. Yeah, 10.30 cm. Okay, that's all. Okay, moving on to question number 14. So here, this is a question from Kinematics of Linear Motion from 5, chapter 8. So a particle moves along straight line from fixed point O. Diagram 14 shows the velocity time graph for the particle, right? So state the time when it stopped instantaneously. Okay, remember, a particle stops instantaneously when the velocity is 0. So here your velocity is 0 here, right? You can see from your what do you call your graph, right? You can see that when t equals to 0, okay, when v equals 0, here, v equals 0, the t is 6. So very easy. When it stops instantaneously, when t is 6. That's all. One mark. Okay, the range of times when the particle moves to the left. Okay, remember, positive velocity means it's moving to the right. Negative velocity means it's moving to the left. Where is the region where the graph or below lies below the x-axis or t-axis, where the velocity is negative? Velocity is negative. Here, move it up. The t value should be anywhere between 0 and 6. So that's it. We just write between 0 and 6. Between 0 and 6, particle move to the left. Then more than 6. After 6, it start to move to the right. All right. Now, next, they say that show that given that velocity time graph is a quadratic function, show that v is t squared minus 60. Okay. It's important that I mention it's quadratic, so we can use a quadratic model, right? Even quadratic, right? You can use a various way to do it. But for me, I look at it, it passes through 0 and 6. So we know the roots are t is what? T is 0, t is 6. We just have to work backwards, bring it over t minus 6, right? Normally we let it be 0, but this one is not 0, so we put v here. And the thing is, we don't know what's the number in front here. The coefficient of t squared, we don't know. Is whether it's 1, is 2, or anything else. So you cannot assume that it's 1. It may not be 1, so we put a. So what we need to do is to sub in another coordinate. You can't use 0, you can't use 6. You have to use this point here, 8, 16. So you sub 8, 16 inside. Your velocity is 16. Your time is 8. 8 minus 2. Sorry, 8 minus 6, which gives us 2, right? Right? 8 minus 6 is 2. Okay, then you times 8, you get 16 as well. My a is 1. So therefore, you sub inside a is 1. You get t minus 6. Velocity is t squared minus 60. Okay? There are several alternatives to this. Now, some people may say, can I use at squared plus bt plus c? You can, but you need to sub in a lot of points. For example, you sub the first point 0, 0. v 0, t 0, c has to be 0. Then your velocity is at squared plus bt. Then you sub in another point. Let's say I sub in 6, 0, right? V is 0, a is 6. This is 36, right? This is 6b, right? and you can make B as a subject. 6B is negative 36A, B is minus 6A. Sorry, I do a bit fast here. I'm just telling you can use this, but I wouldn't do this because it's long. The third point you sub in is 8, 16. Your V is 16, 8 squared is 64, this is 8. Then you divide by 8, I got 8A plus B equals to 2, equation number 2. Then you solve them simultaneously, which is very, very long compared to the method that I'm using here. This is a lot easier. Yeah. Okay. So you can do this, you get the same answer. All right. Now, after you got your velocity, yeah, you're supposed to find the acceleration when t is 2. So I'm going to differentiate this, okay? This is B Roman 1, B Roman 2. Differentiate velocity, you get acceleration. Acceleration is 2t minus 6. And when the t is 2, your A is 2 times 2, which is 4. 4 minus 6, negative 2. Yeah? My acceleration is negative 2. All right, next. Okay, let's read the next part. Find the distance traveled by the particle from q second until 8 seconds, such that q is the time when the maximum speed is achieved. Okay, you notice there's a difference between the Basel and the English version. And so actually there's an error in the question, called law error actually. This is from Q. The original question say P, it's not P. You can see it's supposed to be Q. And we cannot say halaju maximum or maximum speed because maximum speed, this is not maximum speed, this is minimum speed. This is, should I say, this is maximum speed, or we say minimum velocity. Minimum velocity means it travels at the fastest speed in the opposite direction, negative direction, left hand side. Maximum speed, yes, maximum speed means you're traveling fastest, but left hand side, speed has no direction, no negative, right? You can see it's negative, right? So it's not supposed to be maximum velocity, it's supposed to be minimum velocity or maximum speed. So you can change either one, and the question already says sebelum ia bertukar arah or before it changes direction. So we are saying from here, Q, this point here, maximum speed or minimum velocity until 8. So we're finding this area. But to find this, right, we can use, this is part C, right? We can use your A, let it be 0. Because minimum maximum speed happens when your acceleration is 0. Your T is 6 divided by 2, T is 3. So you need to use integration. Okay, either you integrate the velocity function to get displacement function first, then you sub in one by one, or you use definite integral, integrate one shot. I prefer to use definite integral. Yeah, that is the distance travel will be integrate from 3 to 6. Your function is, let me rewrite, the function is your velocity function, which is t squared. Wait, it's not moving. T squared minus 60 dt, and then you add 6 to 8 t squared minus 60 dt. However, take note, if the area under the graph is below the t-axis, this part is going to be negative. So since distance cannot be negative, we either modulus it or we put a negative in front. I personally like to put a negative in front. For me, modulus is right a lot more step, a lot more lines. So I just put a negative. So let's integrate. This will be t cubed over 3. 6t squared divided by 2. 6 divided by 2 is 3. 3t squared from 3 to 6. Repeat this, t cubed over 3. 3t squared, 6 to 8. So what I need to do now is to sub in one by one, okay? 6 power 3 over 3, 3 6 squared, minus 3 power 3 over 3, 3 3 squared. Okay, there's a lot of bracket here. Then you add the second part. This will be 8 power 3 over 3, 3 8 squared, minus 6 cubed over 3, 3 6 squared. Okay, right. Now let's use a calculator to count. First one, 6 cubed is 216. You divide by 3. Then you minus 3 times 6 squared is 36. Minus 3 cubed divided by 3 is 27 divided by 3 is 9. Minus 3 times 3 squared, 3 times 9, 27. Negative 18. So the first part you notice is negative, right? Then you add the second part. 8 power 3 is 512 divided by 3. you minus 3 times 6, 8 squared is 64. This is again 216 divided by 3. And then you minus 3 times 6 squared, 6 squared 36. So I got 44 over 3. Take these two and add together. Your final answer is 98 over 3. 99 divided by 3 is 33, so it's 32 2 over 3. You can leave it as mixed number or improper fraction. One more thing you can do is you can use your calculator to double check. So integrate x squared with x is over here, square, minus 6x from 3 to 6. Okay, you should get negative 18, right? Now, second part, I will change to 8. This is 6 to 8, right? 44 over 3. So I know my answer is correct. Yes? 18 plus 44 over 3, you should get this answer. Okay? Recording. Okay, last question from this paper. So question 15. A fishmonger buys X kg of prawn and Y kg of stingray from a wholesaler. The price of prawn and stingray are 25 and 20. The purchase of the prawns and stingray are based on the following constraint. Two constraints are given as follow. Okay, so the first one, the mass of stingray is Y. Is not more than means less than, equals 3 times the mass of prawn. Yeah, I got my first inequality already. Second inequality, the total amount of prawn and stingray purchase is 800 ringgit or more. Your prawn is 25 ringgit, so if you bought X kg is 25 times X, and your stingray is 20 ringgit per kg, you bought Y, so it's 20 times Y, is 800 or more. 800 more means greater equals 800. Now, normally if you can simplify, we should simplify. I'll divide everybody by 5. This should be 5x plus 4y greater equals 800 divided by 5 is 160. Okay, that's my second inequality. Now, next they say the third inequality is represented by the color region, the graph. Yeah. So right inwards the constraint. Okay, so you can see from the graph, right? It intersect 120, x intercept 120, y intercept 120. You can find the gradient, find the y-intercept, or you can use this x over a divide by y over b equals 1. Remember, x-intercept is your a, y-intercept is your b, the result equals 1. If you multiply everybody by 120, you get x plus y equals 120. So this is your third inequality. Now you can also do like what I said just now. You can find the gradient, negative 120 over 120, which is negative 1. Your y-intercept is 120, so you can use y equals to mx plus c. Bring it over, you get this as well, okay? But this is just the equation of this straight line. We are supposed to write the inequality, yeah? Inequality, you notice is below, the shaded region is below here. So if it's below, right, we need to use x plus y less equals to 120, okay? X plus y less equals to 120. But we are supposed to write in words. That means what? The total inwards are total purchase, total mass of prawn and stingray is less than 120 kg. Yeah, that's how you write in words. Okay, now next, use a graph to construct and shade the region R, which satisfy all the above constraint, the 3 constraint. Okay, I think the third one we already know, so it's already shaded. We just have to find the first two. Y equals 3x. So for me to draw, right, use a table of values. Let x be 0, y be 0. Second one, use another value of x. Maybe I use 40. Y will be 120. 40 and 120 is here. So let's use a ruler. 0, 0 is here. Just join them together. Okay, you notice it looks something like this. Okay, so this is y equals to 3x. Okay, now next you have 5x plus 4y equals 160. Use the table values. Sub x with 0. 160 divided by 4. 160 divided by 4 is 40. Sub y with 0. 160 divided by 5, 32. So you have 0, 40, which is here, and 32, 0. 32 will be around here. So it's a very small or very short line. You start from 40, yeah, around here. So this is 5x plus 4y equals 160. Okay, now we need to shade the region. So here the shading region part, we need to use a different color, right? Because otherwise it looks the same, right? So they shaded this part already. So maybe I use red color. Number one, your y must be less than, meaning it must be below here. Okay, number two, we already know this is below this straight line, x plus y less equals to 120. The third inequality, it must be greater than 160, so it must be above here. So the region of feasible solution should be here. Okay. All right. I'm just going to label with the symbol R. All right. Now, next, by using the graph, find the minimum mass of prawn purchase if 20 kg of stingray is purchased. Stingray is Y. You're finding X. Y is 20. What is your X? Move it across, move it down. It looks like 16. 16 or 17. Okay, maybe my line not very clear. Let me see once again. Supposed to be 16. Supposed to be 16. Okay. So, okay, I'll just take minimum X is 16 kg. Okay, just write 16. Now, the maximum amount of money paid by the fishmonger. Now, remember, this is the minimum amount of money paid, 800. So your objective function follows this because we're talking about amount of money purchased, right? So it's 25x plus 20y equals to k. K is a variable, but k minimum is at 800. You can spend more than 800, but what is the maximum? I don't know. We need to find from the graph. So the moment we draw another line on the graph, okay, maybe I just draw a different color. You normally use the same color, so I just draw another line. This is blue line. Okay, this line must be parallel because it is the objective function, right? Is 25x 20y. It is actually parallel to this line that we got initially. Okay, so let's make it. Okay, sorry, let's make it bigger, longer. Okay, I'm going to take this line and slide up. Now, notice, right? Although this is the highest point, it doesn't give us the largest y-intercept. You want the largest y-intercept, yeah? Right? It passes through this point. Yeah, y-intercept not largest. Y-intercept is largest here. When it passes through 120, you can extend the line if you like, right? The highest here. But do you need to find the y-intercept from the graph? No. We just have to identify the point that gives us the largest y-intercept. The point that gives us the largest y-intercept is 120. I know it's very weird. That means you only buy prawn, don't buy stingray. That's it, right? But yeah, what to do? We're going to use this value. So take this and sub inside 120, or we can say k is maximum at 120. So the maximum value of k is the amount that you purchase is 25 times 120 plus 20 times 0. Use your calculator. 25 times 120, you should get 3,000. So maximum amount you can use to purchase is 3,000 ringgit. All right. Yep, that will be the end of our discussion for this paper. Hope you learned something from this discussion. Thank you for watching. See you in the next video.